I'm now going to continue my review of Danica Mckellar's Math Doesn't Suck book, this one right here, with the following. Alright, addressing Danica Mckellar here, I have to say you start your conversation with disorganized jewelry. As a trained COBOL programmer, and in case you don't know, COBOL, it was a very early computer language. It actually stood, it's an acronym by the way, it actually stood for the Common Business Oriented Language. As a trained COBOL programmer, I always stress organization. I realize how much time organizing your valuables can be, but if things are organized, they are easier to find and are less likely to be damaged. I will admit that complex fractions can be difficult to calculate. So let's start with the fraction 1/8 divided by 2/4. But anyway, it says 1/8 divided by 2/4, which is a fraction right here. It's a complex fraction. Of course, you would start by organizing the denominator of this fraction. But before I proceed further, I have to prove that multiplying by a reciprocal number can be done. So let's pause this math problem for just a moment to justify using reciprocal multiplication. And I think that's something you should have explained in your book, but that's just a recommendation. What is reciprocal multiplication? Okay, we're going to use the following math problem. 1/2 divided by 1/4. 1/2 divided by 1/4. So what is this math problem saying? It's actually asking the following question. How many 1/4 are in the fraction 1/2? Well, the answer to that is very, very simple. If you add the add-ins 1/4 and 1/4, that's right. If you have an addition problem, the two things you're adding are called add-ins, and the answer you get is called a sum. Okay? So if you add the add-ins 1/4 and 1/4 together, you will get 2/4 or 1/2. Simply put, you have two 1/4 in this 1/2. That's what the math problem is actually saying. So you go 1/4 plus 1/4 equals 1/2, like thus. So how would someone like me use reciprocal multiplication to solve the math problem 1/2 divided by 1/4? Okay, so how would we use reciprocal multiplication to solve this? Alright, so what you would do is you would multiply 1/2 by 4. So instead of having 1/2 divided by 1/4, you'd have 1/2 multiplied by 4. Like this. Okay? What is this math problem actually saying? Well, before I tell you that, let's look at another multiplication problem so you can... Some people that I deal with are not as bright as others, and you have to really kind of bring it down like 5 levels before they finally get it. If you send them on what I call what I would consider a linear progression. I know that's an official math term, but it's linear reasoning for me. Okay, and this is how I have to explain it to them. All right, so let's multiply 2 by 4. Well, that would be 8. Well, what if we added 2 plus 2 plus, we still get 8. Alright? So, you have 4 2's in 8, basically. And that's how that works. So, let's compare what I just said about 2 times 4 with 1/2 times 4. Okay? So obviously the answer is going to be 2. Alright? We can also say that if you add 1/2 plus 1/2 plus 1/2 plus 1/2, you also get 2. Half plus a half is 1, half plus a half is another 1, and 1 plus 1, of course, is 2. So there are 4 1/2 in 2. And that's how that works. So let's return to our original equation so we can see that all that actually works. And like I said, bringing the equations down a little bit so they can see it the way it's supposed to be can give them an idea how to step up and learn something else. Okay? So, what is 1/8? 1/8 divided by 2/4. Well, we can simplify the denominator right here. Okay? So 2/4 is actually 1/2. Okay? Using reciprocal multiplication, the problem changes into 1/8 multiplied by 2. Alright. If you have 1/8 times 2 over 1, what you're going to have is 2/8. Or otherwise, 1/4. And if you add, hold on, 1/8 plus 1/8, because you got 2 1/8 in 1/4. So basically all this checks out. Getting the idea here? And that's a good way to explain everything. I know it's a slow way to explain everything, but you want to explain things to some of these students very, very slowly, because if you don't, they may not catch it the first time. Now then, let's discuss mean and extreme kids. Okay? Now I'm going to help people remember both. Mean kids are people who tease innocent victims. Extreme kids are risk takers. So let's use the 1/8 divided by 1/2 math problem to illustrate the mean and extreme kids. Let's go back to our original math problem. Mean kids huddle together while extreme kids jump over them and slide under them. So here's the mean kids right here, the 8 right here and the 1 right here. And then the extreme kids are these. You see how the mean kids huddle together while the extreme kids are jumping over the mean kids and sliding under the mean kids? There you go. Let's multiply the extreme kids first. Okay? What is 1 times 2? Well, that's going to be 2. Okay? Now let's multiply the mean kids. What is 1 times 8? Well, that's going to be 8. So we got both results right there. So, the extreme kids are above here. The mean kids are below them, as they should be. And now you have a fraction 2/8 or 1/4. That's a good way to illustrate things. As you can plainly see, we got the same result. So personally, I think that students can relate to this better than they can to a severe thunderstorm. I mean, yes, there are lots of severe thunderstorms, but unless you live in the Midwest where you're getting some of the most severe, and we ended up with some pretty bad storms this past week, but nothing compared to some of the stuff they've had in the last few. Now, I will say that if I recall correctly, it was late April or early May, probably early May, when we actually had a tornado around here. That is not a joke. It didn't exactly hit where I was, but it was pretty close. All right. So, unless you've lived through something like that, yeah. Anyway, I mean, what about people that live in the desert? The next part of this lesson that you had in your book was about a more complex mathematical problem. So let's cover ourselves with just a little more mud. Alright, so now we have 1/8 plus 1/4 divided by 3 plus 1. Alright, so now here's your new math problem. 1/8 plus 1/4 divided by 3 plus 1/16. How are you going to solve all that? Obviously, we can multiply the fraction 1/4 by 2/2 to get a better numerator. Well, if we multiply like that, what we actually get is that, 2/8. And 2/8 plus 1/8 is actually going to equal 3/8. Now you still got the bottom part to deal with. Now let's multiply the 3 over here by 16 over 16. We now have 3/8 divided by 3. Okay? Now if we multiply this together, what we're going to get is actually, and we can do this by calculator, most people do it these days, or even by their computer, that is. So we're actually going to, in my day it was calculator, now it's computer. But now we get 48/16 plus 1/16, which of course leads to 49/16. Then you recommend canceling factors without proving that a student can cancel factors. So I will take the time to prove factor cancellation. Let's start with the following math problem. Okay? We're going to forget about this for a minute. Now we're going to go with a new problem here. 2/3 times 4/16. So, what happens if you multiply this all the way through? Well, what you'll get is 8/48. That's what you're going to get. Can you do the same thing by canceling factors? Well, let's find out. 16 divided by 2 is 8. Well, here's your 2 up here. And here's your 16 right here. If we do that canceling factors thing, what we're actually going to end up with, and here we're going to write it down, we're actually going to add what we're going to find out here is that we got a fraction of 1/3 times 4/8. Just like that. Well, that's simpler to solve. Well, we can solve this a little bit more. Now we got a fraction of 1/3 and 1/2. See that? Well, 1/3 times 1/2, of course, is going to be 1/6. No further proof needed on that. Now let's go to the original problem that we had. Now we got a bit sidetracked. Of 3/8 divided by 49/16. Now then, we're going to multiply by the reciprocal. Now, 16 divided by 8 is 2. You have a 1 over here and a 2 over there. So now we have the problem 3 times 2 and 1 times 49. Well, 3 times 2 is 6, and 49 times 1 is 49. So this leaves us with 6 49s. Okay, and we could actually reduce this a little bit further if we wanted to. I mean, I'm not going to do it here, but we could reduce this. It'd be a little time consuming, but we could actually do it. But we'll stop that right there. Now at this point, that should have been the end of your that should have been the end of that particular chapter of your book, but it wasn't. Instead, you decided to confuse your students further by discussing order of equations. And what do you use as a mnemonic device? And for those of you who do not know what a mnemonic device is, ask me and I'll tell you. Okay? You take your students to the Arctic Circle. Talk about cold shoulder. Woo. Alright. Now normally my students would follow Harry Lorraine's memory techniques when it comes to acronyms. But I will use a similar idea to help students, at least my students, remember this acronym. First, my students should imagine getting a perm at a beauty shop. Okay? That's a much warmer way to remember this. And I would have them imagine a lady getting the perm, and if you imagine this lady getting that perm, she's wearing a sweater full of dags. Now, what the heck is a dag? Alright? Now, if you don't know what a dag is, I want you to research it because it has something to do with sheep. Okay, and that's why I refer to the sweater. Okay? If you look up the word D-A-G, you'll see that it refers to sheep. Okay? Alright, so what does this acronym actually stand for? Well, it means that, first of all, you in any math problem, you calculate anything in an equation that is in parentheses before you calculate anything else. Okay, so if you have, let me show you this. So if you have an equation like this, you would take that and you'd have 6 plus 4, which would equal 10. Okay? That's what you'd have. You'd multiply the 3 times 2 first, which would give you the 6, and then 6 plus 4 would actually be 10. So whenever you see a parentheses, that gets the highest priority in a math equation. Alright. Then you simplify any exponents, if it's possible to simplify those exponents. Then you multiply and divide numbers in the equation before you add and subtract any remaining numbers. So what do I mean by this? Okay. Let's say you have that equation. What are you going to do first? Well, 5 squared is 25 times 3 plus 2. Well, 25 times 3 is 75 plus 2 equals 77. And that's how that works. You're simplifying the exponent, then you're multiplying these two numbers together, and then you add afterwards. And that is why I used that particular acronym. Okay? Finally, you apply this order of equations to complex fractions. Well, I could have told them that. I feel you should have devoted a separate chapter of your book to the order of equations before composing your complex fraction chapter. I feel that many students would become quickly confused if they saw it any other way. And then, after all that was done, you finished the chapter with an unrelated quiz. Well, that's fun, but what does that have to do with what we were talking about in the first place? I would have presented this quiz in a later chapter of your book, and perhaps presented this quiz at the beginning of the book. If students can't focus properly on complex fractions, it's unlikely they'll be able to perform simple arithmetic. And that is my critique of that particular chapter of your book. I want to thank you very much for sticking with me and watching this presentation. And I look forward to reviewing another chapter of your book very, very soon. In the meantime, you have yourself a wonderful evening, and I will tell you more in my next video, so I'd like for you to stay tuned.